Example 1. Form a degree 4 polynomial in expanded form with the following zeros, I, 2, and -2. Then verify with the graphing app and sketch the function below. So let's look at f of x as a product of its linear factors. First of all, due to the conjugate pairs theorem, if we have I is a 0, then -I is also a 0 because imaginary roots come in conjugate pairs. Okay, so we'll have x minus I, the one that was given. We also know we have x minus -I, which will simplify to x plus I. Then we had the real 0 of 2, so x minus 2, and the real 0 of -2, so x minus a -2 is x plus 2. Now we have a lot of multiplying to go and do. I'll do the conjugate pair product first. So x squared plus ix and minus ix, the inner and the outer products will cancel each other, and then I'll have minus I squared. And I have the minus plus pattern here. X minus 2x plus 2 came from the difference of squares because the inner and the outer products there will also cancel each other. But let's rewrite x squared minus I as x squared minus -1, because remember I squared equals -1. So that will become x squared plus 1. So eventually we'll be able to take this shortcut and know we square the first term and square the imaginary term and then say plus, because I squared is always -1. Now we still have to multiply x squared plus 1 times the quantity x squared minus 4. We just have to do a distribution of x squared and a distribution of +1. So we'll have x to the 4th minus 4x squared plus x squared minus 4. We have two like terms. So finally, f of x in expanded form is x to the 4th minus 3x squared minus 4. Now I already know several points on this graph. I know I have two real zeros, one at -2 and one at +2. I can also read the y-intercept is at -4. So I'm going to count on the y-axis by 2's. So I know I'll cross the y-axis there. I also know the look of the power function x to the 4th will look like a parabola in its forwards end behavior. So as x goes to positive infinity, y is going to positive infinity. As x goes to negative infinity, y is going to positive infinity. So I know I'm becoming -2 from above, and I know to the right of +2 I'll be going on forever. So there might be some other things going on between those, and we can look at Desmos, but usually when we have imaginary zeros, we have that W shape for these quartic functions. So we're going to dip down below -4 and come back up and do something like that. So let's look at Desmos. I already brought it up in my Chrome window here, and I've typed in the function in its expanded form, and indeed we have a function that looks like a W curve.